Okay.
All right. Good afternoon, everybody. My name is Charles Nebeze, and I'm joined today by my colleague, Lenisa Moodley, and also joined with the CEO and founder of Ambra, Eric Leroux. Eric is going to be presenting webinar number 16 of the 16 approved MICA projects, and his presentation is going to be on the Intelligent Positioning System, revolutionizing safety in mining. But before we jump into Eric's presentation, we again want to reiterate that we do have 16 projects that were funded by MICA, and Ambra Solutions Inc. is one of those projects. And we have been doing webinars for all 16, so you can just check out our channel, YouTube, you'll be able to see all 16 presentations. We also have this screen up so that any of you who want to participate in the currently open call for proposals, you can just click on this QR code right here, and you'll be able to access that call for proposal process. Now, it gives me great pleasure to hand over the presentation to Eric Leroux, who's going to present to us Ambra Solutions Intelligent Positioning System, revolutionizing safety in mining. Go ahead, Eric.
Thanks, everyone. So let me share my screen right now. So there you go. So thanks, everyone, for watching. Let me just introduce Ambra Solutions. So for the past 15 years, Ambra Solutions has been designing, deploying telecom networks for mining environment. So we started in the open pit business 15 years ago, and then quickly after, we've been covering underground mining as well. So as of today, basically, we've been expanding a lot in the past years. We do a lot of turnkey solutions where we package everything, including the hardware, the engineering. We do manufacture devices, component, and then we provide, of course, 24/7 to all our customers. We now have several offices. We have projects in more than 7 countries. We've been covering over 700 kilometers of underground tunnels with 4G, 5G technologies. So the number of connected machines now has been, have been exceeding over 1,000 right now. And again, the whole thing is how can we improve the safety of the worker and how can we make mining companies more efficient? So this is what we've been working on for the past years. So really what's important is how can we quickly deploy an infrastructure which is robust enough and reliable enough in order to enable new use cases that were not possible before. Before, as you know, there was only a basic voice communication using a leaky feeder in underground mines. Today, thanks to 4G, 5G, it's opened up a huge amount of new use cases that are being used today. And that's what we're going to explain today. We're going to focus today really about tracking. But just to let you know that once you have that 4G, 5G infrastructure, now you can do, of course, remote mining operation. You can have real-time tracking of the worker, of the asset. You can have ventilation on demand. So really, you'll see that today, it's really a disruptive technology that allows mining companies to be more efficient. So the goal is always to provide an ubiquitous coverage, to have a full coverage, both underground and above ground, typically. So no matter where you are connected. Today's worker, they want to be connected. They want to be able to download the data sheet on the internet, be able to contact their supervisors. But what was missing up to now was a really simple and precise tracking system for underground mines, basically. So we call it the Ambra IPS, basically. So today I'll explain to you how we do this both above ground, underground, and I'll talk to you about the system and the ecosystem and how it's composed up, basically. So before, without IPS, we knew there was a tagging board, so you knew that the people, the worker, were either underground or above ground, and that was pretty much it. Now, thanks to our system, we know where they are, and basically, if they have a cap lamp with a good battery voltage, if they are in a refuge station, we can even do biometrics, basically. So it's really a leap forward. So where now we can track and help and improve the safety. Of course, we're trying to leverage LT infrastructure. So the tracking system is taking advantage of the 4G tracking capabilities. And also we're adding additional component in order to increase the accuracy of that LT tracking system. So we call it the IPS, where basically it's a mix of software and hardware that is being deployed in a mine in order to provide such an accuracy, basically. So in terms of underground mines, you'll see that we're adding what we call beacons, BLE beacons underground, and we combine the LTE and the BLE technology in order to provide that tracking capabilities. Now for above ground we use standard GPS positioning. So basically, and what's interesting is we can track whatever an asset or people, whatever they are underground or above ground, and then we can do a match and making sure that we know in real time where they are. But where the magic comes is really when it comes underground. So this is where our system allows today to, of course, enhance and improve the VI creation by making sure that all of the workers are in a safe position, safe situation, basically. But we can add a lot more use cases, such as round trip calculation, traffic coordination, even ramp status, as you'll see later today. So what's important is how do we present this information, basically. So we have different ways of presenting that information. In all of the case, what's important is the data belongs to the end customers. We've seen in the past years that big data was a big deal, but sometimes it was difficult for mining to own the data. Here, this is simple. The data belongs to the mine, and the mine has full access to that data. So they can pull the data from the system, they can export it to their own existing system, or export it to a third-party system. So it's either available through a tabular interface. I'm showing here a 3D interface, but really what's important is we provide all of the APIs I'll show you later today in order to pull that data. So now that allows you to have a real-time visualization of the mine. In order to have this working, we need several components, as I mentioned. Some components are physically installed underground. Some component could be a software. Some other component could be a small PCB, so a small piece of electronics that is installed inside a cap lamp, let's say. And we're agnostic in terms of cap lamp, so we can insert that PCB into any cap lamps out there, basically. So the IPS itself is a software. So this is really what we've been working on, and what MICA allows us to improve is how do we make that core even more efficient, more powerful, basically. So that's why we've been adding APIs using the JSON protocol, where third parties can pull that system and get the data in real time. We've been working with companies such as Aviva in order to pull the data to Historian, and then you can make a decision whether it's turning on a fan or
low battery,
or basically working with other applications. Then here's an example of when the beacons are not present, we still rely on the LTE. So the LTE will provide us a tracking positioning. So we'll know a low precision accuracy everywhere in the mine. So we'll know where the workers are, on which level they are. But as soon as we're adding additional beacons, this is where we're adding accuracy, and this is where we can be pretty accurate in terms of positioning. So here's an example of the API. So that API is provided to all of our customers. So it's really easy to do testing, to download XYZ coordinate for all of the asset, all of the workers, all of the machine, basically. Then we have hardwares that we manufacture that can be used. Again, we've been working with third-party hardware, so it doesn't have to be our hardware. And we've been working with other vendors where we've been providing the API, and basically they've been feeding that IPS using standard MQTT protocol. Now, the hardware that we manufacture comes with different flavors. We have a more rugged version, which allow to connect several Ethernet port, allows not only to track, but also to remotely control machines, to have some CAN bus interface, IOs, and so on. Then we have a more light version, which allows to track more light vehicle, pickup trucks, compressors, all kind of auxiliary equipment. We have the PCB, which is included into the cap lamp. And we also have an application that can run on any Android-based phones, basically. And all of those can report its data to that tracking engine, to that IPS tracking engine. Now, in terms of beacons, this is an example of a beacon that is added to an existing infrastructure or to a new infrastructure. So that beacon provides a BLE signal. that is used by all of the devices that are nearby, basically. And the advantage of that beacon is several, but first of all, there's no battery to replace. That beacon is fed through the inline power from the coaxial cable. And also, the beacon can provide a DC output anywhere in the mine. So it is possible to power any external devices, such as a light, a camera, a phone, from that beacon, basically. So it's really these multiple functions to that beacon. In order to power those beacons, we have what we call a DC injector that is installed in a mine in a specific location where we inject the power into the network, basically. So basically, we have other devices that are being added as part of that project with MICA. So we'll be adding what we call a smart load in order to monitor the status of the cable itself. So if a cable gets damaged during a blast, we know right away. We don't have to wait for someone to go into a location and to report an issue. The system will report and will be proactive, so we can set threshold. And then basically, somebody can go fix the cable if it's been damaged during a blast. So we have real-time data, we have geo beacons, geolocation, and we have also asset tracking. And asset tracking is something which has become more and more popular, where you want to track, let's say, a toolbox. So now it's possible to buy disposable tag that you put into some asset that you want to track. So now I can tell you in real time, where are your assets in the mine? So this is something which is supported now by the IPS system. So let me show you an example here of the output of the smart load. So you can go back months and months and see what happened. Do you have a slow degradation, or you have something quick? So this is something which that data is being processed and being presented either a graphical interface or tabular interface to the end users. So really the advantage that we have here is we're solving a lot of problems in terms of traceability, real-time tracking. We can generate what we call dynamic heat maps, where basically we can say, okay, where do you have traffic? Where do you have a bad road condition? Where do you have a bad LT signal? So this is something which can be done in real time. And that helps the workers and the support from making sure that it's always up and available for 24/7 operation, especially when it comes to autonomous mining. This is something which is really important. So our system, we've been submitting a lot of patents, by the way. So we have now patents in several countries, as you can see. And the goal here is to expand and to make sure that the Canadian technologies can be sold and can be used anywhere in the world. Canadian is a leader in the mining technology, and we want to make sure that we can improve this everywhere in the world, basically. So here's an example of a use case. So we've been working, as you know, with Agnico Eagle. Agnico has been using our platform for several years now, and they had some challenges, basically, where now, thanks to the IPS, they are able to do real-time tracking, to do remote operation, improve the productivity. But basically, they've been doing a lot of evacuation testing. They were able to prove that now with that system, the workers are safer and evacuation is much quicker than it used to be before. And what's coming up in the future, that's interesting, because now they're coming up really advanced requests where they want to know, okay, my ramp, how can I improve the traffic in my ramp? As you know, now we have what we call an accelerometers in all our devices. So we can basically know, okay, where there's a bad road quality, where should I send the grader in order to fix the road? So this is something now which you don't have, again, to wait for someone to notice. The system will be proactive and will tell you where to fix and where there's an issue in your mine, basically. Really, the impact for MICA, for us, it's a huge impact, because there's going to be a lot of investment that's going to be done here in Canada. So a lot of new people will be hired, a lot of new technology will be developed. And of course, that's going to help workers not only in Canada, but workers in minings everywhere in the world. So this is really important here, where we're exporting that technology to several countries, and those countries are now leveraging Canadian technology. So this is really what I wanted to present today, to share with you today. And we're really happy to work with MICA on the development and improvement of that IPS platform. Thanks.
Awesome. Thank you very much, Erica, for that presentation. You know what, I actually have a more clear understanding, you know, on the ideas around asset tracking, asset condition monitoring, and just a whole issues around the asset, even your conversation about even monitoring the line itself as an asset. So that's very impressive that you're very focused in that way. But my question for you is, for a mining company that, you know, doesn't have obviously the Ambra IPS solution in it, what are some of the minimum requirements for a mining operation for them to be able to adopt your technology?
That's a good question. So the IPS, as I mentioned, has both software and hardware. So let's say they have nothing. First of all, they can just use the software with any infrastructure, basically. So basically, we're agnostic. We're working on any IP-based infrastructure. So what we're proposing is for them to either test the technology using some kind of we have a cloud-based system which they can download application. They can test it themselves, basically. We can also send like an on-premise software, so if they want to test themselves. But what we're recommending also is to come to some of our customers and see the system from working in a live environment. This is really impressive to see this. Like you see people using that system on a day-to-day basis, how they're using the system and so on. So there's several ways for our customers basically to test the system, to know how to use it, and to know the benefit and how it's gonna improve their efficiency. So I invite all of those customers to reach out to us. And no matter what they have in terms of infrastructure, we can definitely help them.
Thanks, Eric. So that brings me to the next question. How easy would it be for a customer to have a demo of the IPS?
So depending where they are located, if they are located in countries where we have customers, we can easily arrange a visit. If they are remotely located, we can definitely do some kind of a virtual test, or we can send them the software so they can download the software. Again, they can use a cloud-based version. We can do a team session with them. So there's several ways for our customers or for potential customers to have a look at how that system works.
Right, and just to go back to the device use or the beacons, you say they're not on batteries. How are they powered again?
That's a very good question. We have both. We have battery beacons, but as you know, a battery needs to be replaced every couple of years. And then we have beacons that are powered in line. That means that we're injecting power inside the cable. So the cable that are being deployed in the mine can not only carry the 4G, 5G technology, but they also carry power in order to power devices such as a beacon. So that way, those beacons will be always on, no battery to replace, to throw in the garbage. But also that system will be able to power other systems, like I was explaining, maybe like a light, camera. We have a lot of customers having like live camera feed from underground now, and they use the power from that system in order to power the camera. So this is an example of how we've been developing a system to provide both tracking but also power everywhere in the mine.
Gotcha. Thanks for that explanation, Eric.
You're very welcome.
Okay, so my next question, Eric, is around regulations, and especially government side regulations or any standards. Are there any regulations that you think are in the way of your solutions being adopted, or are there any regulations that you think are important to highlight if somebody wants your solution?
That's a very good question. So regulations is usually tied with the LTE technology, the 4G, 5G technology. So depending on the countries, some countries may be more difficult to get what we call spectrum. So that's really important. The first thing we need to check is there any spectrum available to deploy the 4G, 5G backhaul? Because tracking can be done using all kind of backhaul. But if we're talking about an LTE backhaul, it's important to check for regulations. Usually underground is slightly easier to get spectrum underground, where above ground is really important to work with a spectrum owner or to work with the regulators of the country to get access to spectrum. So once you have, let's say, the network in place, then adding tracking is something which, as long as you have a connectivity, is something that can be added. So it's really important first to make sure that you have that backbone with making sure that we comply with local regulation, and then we're adding the tracking capabilities on top of it. So good question, Charles, because this is sometimes a roadblocker for some companies. The regulation.
Gotcha. Thank you for that answer, Eric. My next question is around the amount of work that the mining company is expected to do when they adopt your solution. Because the reason I ask the question is sometimes, the vendors, the vendors, we don't tell the mining companies what it's going to cost them in terms of time and resources just to install the solution, not necessarily to buy the solution, but just to make allocations to install it. Can you maybe just comment on what should a mining company expect for them to do themselves in order to adopt your solution?
Okay, we've been designing our solution to adopt the KISS, keep it stupid and simple. So underground, it has to be really simple. So for us, the intelligence resides above ground, where underground, it's as simple as possible. We train like electricians, we train people. You don't need like engineers or skilled IT people to deploy that solution. It's important that our solutions can be deployed by anyone underground and can be troubleshooted by anyone underground. So typically our customers, just to give you an example, will deploy up to 1.5 kilometers per day of that solution. So it's really quick to deploy it. So it's like plumbing. You just keep adding cable as the mine expands. So it's important for our solution to be not a static, but a dynamic solution, where depending if the mine changes, they don't have to call us every time. The mine themselves, they are trained in order to expand and to install that solution. So this is one of the key difference between our technologies and other technologies out there.
Gotcha. Thank you for that. Lanissa, any other questions from your side?
Well, just if you could share which countries you're in. I think you may have had a slide on that.
I did, and we're now in more than 7 countries, and we're going to be expanding a lot more countries next year. So we have a lot of countries now leveraging that technology, but some of the countries are, of course, Chile. We have an office in Chile, Mexico, USA, Australia, Africa, Suriname. So we have a lot of countries now using our technologies.
Very cool. Thanks.
Yeah. Maybe one last question from my side, sorry, is I know that the mining industry is going to have a skill shortage, right? And my question is, what skills do you feel, Eric, are needed by the industry in order for the industry to more comfortably adopt solutions that are coming from a company like yours?
Well, of course, we need those mining companies to have some skilled workers in like information technology above ground. So they'll have to deploy more VMs, networking capabilities, right? They'll need people that knows the IP protocol. So this is something which mining companies, they'll have to have those kind of skills. Any system today is based on IP, whether it's a scoop, an LHD, a tracking system, you need some IP background. So that will be a thing. Mining companies will need to have a minimum of skills in IP, in networking. I mean, but again, we try to minimize that number of workers that is needed, because we know there's a skill shortage and we know this is a challenge. So this is why our solutions has been so popular with remote minings, because mining companies now, they have to do more with less people. So by enabling remote operation, basically those people can be above ground, can be remote, can remotely control more than one machines. So this is something which is important today, and this is something which will allow those mining companies to be more efficient in the future.
Gotcha. Thank you for that. And Eric, one of the things we've been doing is in all our presentations, we'll be giving our presenters the last word. So if you have something you want to say to the mining industry or to the ecosystem, please go ahead and say it now, and then we'll close the presentation. Go ahead.
Well, I would like to thank the mining industries, and I'm happy to see that mining industries now is using more and more technologies with workers that are younger and younger. Those people, they're asking now for technology. The new people, as part of that skill shortage, based skill worker shortage, they will want technologies, and now we have it. So that's why I'm happy now to present this to any mining companies. They will now be able to leverage that technology to keep their worker happy and efficient. And Billy, that's my last word I will have for today.
Awesome. Thank you very much, Eric. Really appreciate you coming online and for this presentation. And to everybody who's been listening to this presentation, here you have it. You know, there are solutions out there that can actually help your mining operations to become better. So thank you very much for that. And thank you, Eric.
You're very welcome.